Hi all, welcome back. And in this video, we are going to learn about Toset. So in earlier video, we learned about Poset and Poset we understand like this, that it consists of a set and corresponding operation on set such that R is a partially ordered relation over S. So this is called a poset and it is denoted by this, right? In this video, we are going to learn about something called Toset. So let's say what do we define first, that let P is a set and there is a operation, this one be a poset. Okay. So if there are two elements. So first of all, we define that P is a set and this is an operation for poset. So this is an operation over P and let's denote it by a poset. So there are two elements, let's say A and B. So A and B belongs to P and these A and B are said to be comparable. Two elements A and B are said to be comparable comparable if A is somehow partially ordered is somehow a subset of B and or B is poset for has a POR over A. Okay, so this is a symbol that denotes POR. Okay, I mean partially ordered relation. So if A and B are two elements that belongs to P, and let's say that this is an operation over poset. So if A and this operation over B and B is has a this operation over A, so we can say that this is a these are comparable. Let's see what do I mean by this. So if we have a set called A and it consists of 1 2 3 4. Okay, and let's say that a is a set and this is an operation over A less than equal to, and let's say this is a poset. Of course this is a poset, we already have seen that less than equal to is a or greater than equal to is are opposite onto Z. So this is a some kind of Z set of integers. Okay, so what we say that let's say two elements. Okay, let's say 2 and 3. Okay, so if we take 2 and 3, so 2 is less than equal to 3, right? So this is something, this is an operation something like this. Okay, so 2 is less than 3, so we can say that 2 and 3 are comparable. That is what we have defined above, like that if there are two elements, so here is our set P and this is an operation over P such that it is a partially ordered relation. So this is a partially ordered relation over P. So if two elements are there, A and B, that belongs to P, then they are said to be comparable if A has a relation, partially ordered relation with B, or B has a partially ordered relation with A. Okay, so this is what I meant. So in this example, it is much more clear that if A is a set and less than equal to is a partially ordered relation over A, then 2 and 3 are comparable if 2 is less than equal to 3. Okay, if we say 4 and 3, so is 4 less than equal to 3? No. Okay, so we can't say that 4 and 2 are comparable or 4 and 3 are comparable. So 4 is not comparable with 2 or 3, and 4 not comparable with, or we can say that 3 not comparable with 4. Okay, so we can define it like that. So 2 and 3 are comparable if 2 is less than equal to 3, but 4 and 2, if we compare 4 and 2, so 4 is not less than equal to 2, but 2 is less than here just a second, I just misprint this part. So 4 is not less than equal to 3, but if we just reverse the direction, that is if we say 3, so 3 is less than equal to 4. So this is 3 is less than equal to 4, but 4 is not less than equal to 3, right? So 4 and 3, if we ask, so these are not comparable, but 3 is less than equal to 4. This is comparable. Okay, so if we have 4 and 3, so we have to consider both this scenario, right? And here, if you see in the definition, it is not saying that for and, it is saying that or. So you have to mention this, you have to remember this, that we are checking or. Either A is comparable to B or B is comparable to A. So if I clarify this part, so let's say again, if P is a set and this is a partially ordered relation over P, and this together is a poset. So if A and B are two elements belonging to P, then A and B are said to be comparable. A and B are comparable. A and B are comparable if A is has a partially ordered relation with B, or B has a partially ordered relation with A. So we have to check either. If either of the condition is present, if this is present, this is present, it is well and good. If this is present, this is not present, then also they are comparable. If this is not present, this is present, then also in all these cases, these are comparable. So A and B are comparable. Okay, but if either one of these is not present, then they are not said to be comparable, right? So in this case, if you see, let's say we have this A and it is equal to 1, 2, 3 and 4. And here if you see, if A is a set and less than equal to is a operation defined onto A, then we say this, it is a poset. And if we take two elements, let's say 2 and 3, so 2 and 3 are comparable because 2 is less than equal to 3, but 3 is not less than equal to 2. Okay, but this condition is satisfied, hence 2 and 3 are comparable. Similarly, 2 and 4 are also comparable because 2 is less than equal to 4, although 4 is not less than equal to 2. But if this condition is satisfied, we can say 2 and 4 are comparable, right? So this is the condition. Let's say one more thing. If we define a division operator, so again we have the same set A, and let's say we define a division operator and it is a poset. We know that division operator on a set of positive integer is a poset. So if we write 1 and 2, so 1 divides 2, right? So 1 divides 2, it is true, hence 1 and 2 are comparable, right? If we say 2 divides 1, so in this case it doesn't divides, but 1 2 does divide. So you have to take either condition. Similarly, 2 and 4, so 2 and 4 are comparable. Why 2 and 4 are comparable? Because 2 divides 4, although 4 doesn't divides 2, but 2 divides 4, so one condition is satisfied, right? So that is why 2 and 4 are comparable. But again, here let's there is one case where two elements are not comparable. For example, if we take 2 3, so neither 2 divides 3, okay, nor 3 divides 2. So both the conditions are not satisfied. Hence, we can say that 2, 3 are the two elements belonging to A, where 2 divides 3 is not true, or 3 divides 2 is not true. Hence, 2 and 3 are not comparable. So this is one case where we get this part. Okay. So this is about comparison. Now, why we are learning this part is because here we are going to learn of Toset. So what does Toset means? So Toset means that total set, like if we have this A and it consists of elements 1 2 3 4, and we are defining a poset such that A we are defining a poset, a relation less than equal to onto A, and this is a poset. So for this particular partially ordered relation, if we take any two element 1 2 2 3 3 4, any two elements, okay, 1 4 3 4, any two elements, then definitely the relation this exists. like 1 is less than 2, 2 is less than 3, 3 is less than 4, or 1 is less than 4, or 3 is less than 4, something like this. This does exist for every pair of this A, right? Hence we call it a Toset. So 1 is less than equal to 2, 2 is less than equal to 3, 3 is less than equal to 4. So for every two elements belonging to set A, we can check for this relation, and this yields true for either one. Like if we check 1 2, so 1 is less than equal to 2, although 2 is not less than equal to 1. Any you just take any two elements, like you take 1 3, so 1 is less than 3, so this is 1 and 3 are comparable. Every pair of the set A is comparable, hence it is called Toset. We can say here every pair of set A are comparable. Okay, hence it is called a Toset. But if we take this another relation, another poset, so that is A, and we are defining a division operator onto this. So if we for this, if A consists of elements like 1 2 3 4, and if we define division operator, if we take any two elements, so 1 divides 2, hence 1 and 2 are comparable. Okay, but if we take 2 divides 3, so this is not comparable. Why? Because we take either like 2 3, 2 doesn't divides 3, or 3 2, 3 doesn't divides 2. So for both the cases, this division operator is not valid onto this two pair, right? So it is not comparable. So here it is not a Toset, but it is a Poset. Okay, 1 divide 2 divide 3 divide 4 is a Poset and not a Toset. So this is the basic difference. That's why I went through this comparable part. Now let's go through the formal definition of Toset. So what is a Toset? So Toset is a Poset. So Toset is a Poset written as P, and this is a partially ordered relation sign in which every pair of elements in P are comparable are comparable is called Toset. Sorry, it's called Toset, or you can also call it as totally ordered set, right? A poset in which every pair of elements are comparable is called Toset or totally ordered set. Okay, or it is also known as chain. We can also call it as a chain. Now let's see the definition. What we need to cover rest is let let P is a set, and this is a POR defined, and let this is be a poset. Okay, so if we define something called associated relationship associated relationship okay, so we define it like this sign, associated relation. See, this is a sign of POR, partially ordered relation, we already have seen. Okay, and along with set on which it is defined, we call it as a poset. Okay, now we are moving towards this associated relationship, which is defined with this symbol. Okay, so what does associated relationship mean? So that if there are two elements, X has an associated relationship with Y, this means X and Y are comparable, but X does not equal to Y, is not equal to Y. Okay, so X and Y are comparable. This is a comparable sign. X and Y are comparable inside this partially ordered relation, but X is not equal to Y. So this is called the associated relationship. Okay, so keep this in mind, because we are going to learn about Hasse diagram, and this is going to be useful in this case. So if X is defined like this, has an associated relationship with y, it means x and y are comparable, but x not equal to y. Similarly, the next thing we are going to learn is covering. Okay, so this is associated relationship, and next is covering. So what we call covering? So y covers x, y covers x means x is somehow related to y. I mean, x has an associated relationship with y. This is y covers x, right? X has an associated relationship with y, and x has an relationship with z, and so x and z are comparable and z and y are comparable. That means that means x equal to z or y equal to z. Now, what does that means? We'll see. But first, understand this part covering. So I think associated relationship is clear. We are defining this with this symbol, and x has an associated relationship with y means x is somehow comparable to y and x is not equal to y, these two condition. But now we are going to learn of covering. So covering, we will see more about covering in hash diagram, but I'm just giving the introduction here. So covering means if covers x y covers x, that means x is has associated relationship with y, and x is comparable to z, and also it is comparable to y, and that implies x equal to z or y equal to z. Okay, we'll see what does that means in the upcoming video, that is hash diagram. So I think, I hope some of the concepts related to poset, toset, por, compatibility, and of course associated relationship and covering I made clear in this video. If you do have any comments or question, please do post your comment in the comment section, and next video we will be seeing about hash diagram. Thank you very much.